So picking up where we left off, asking yourself the question, like, do you have to do quadratic formula? Hopefully not. Let's take a look at this one. And remember that I want to move the least amount of things. So I'm going to go ahead and move those over. So if I add the 2x, I would get 5x. And then if I subtract the 5, I would get -1 equals 0. Okay? And then I'm going to ask myself if it factors. So sum to 5 and a product of 3, well, there's nothing there. Okay, I don't want to do completing the square with this -3 and the 5 and the fractions. So I have no choice here but to do quadratic formula. Now, if factoring is always kind of your first option, it's going to equal 0, but these don't have to equal 0. So if you come back up here, okay, and you make a little note, if it's factoring, it needs to equal 0. And if it's quadratic formula, it needs to equal 0, okay? But square root and completing the square don't equal 0, and they don't have to equal 0. When you're solving by completing the square, this equaled 5, and that's fine. But when you're factoring, it has to equal 0 in order for you to factor it. So if you're going to do quadratic formula or factoring, you need to make sure that it equals 0 so you have your right values for A, B, and C, and everything is good to go, okay? So back to this, I'm going to be stuck doing quadratic formula. I know that A is -3, B is 5, and that C is -1. And that goes back to that AX squared plus BX minus C form, okay? So from here, I'm going to do quadratic formula, and I'm just going to plug the numbers in. I'm not going to try to worry about simplifying anything yet, okay? So if I do this, so I have x equals -b, so that'd be -5, plus or minus the square root of b squared, so b squared is 5 squared, minus 4, and then a was -3, c is -1, all over 2a. So that's 2 times a is -3, okay? And then you can just kind of double check, did you plug everything in correctly? So -b plus or minus b squared minus 4 times a c all over 2 times a, okay? 2 times -3 is just -6, okay? And then if I keep going from here, I know that -5 plus or minus the square root, 5 squared is 25. I have 3 negatives here, so that's going to stay negative. And 4 times 3 is 12. All over -6. Well, 25 minus 12 is just 13. And 13 is a prime number. There's nothing to simplify there, okay? But there's one more thing that's left. If 2 negatives make a positive here, don't say -5 over -6. Like -5 over -6 is just gonna kind of simplify to be 5 over 6, and so that's one where I would just leave it. Oh, you know what? I messed up, y'all, and maybe you caught it before I did, but this should be -5 up here. So the -b should be +5, and then this should be +5. My bad on that. I'm not going to re-record this. Okay, so I messed up, and I'll just backtrack. If you add 2x, you guys probably caught it before I did. You get -5x, so -b would be 5, and then b squared would be -5 squared, which is still 25. So I don't have to worry about that kind of double negative there. So if you did have 2 negatives, which you don't, then just change them to be positives. If you have 1 negative, it doesn't matter if the -6 is there, or if you had -5 over +6, you just have 1 negative in the mix, okay? This is another reason why quadratic formula is your last resort. So our answer here would be x equals 5 plus or minus the square root of 13 all over -6. So kind of just to reiterate, if you have like -1 plus or minus √3 over -2, just change that to be 1 plus or minus √3 over 2, okay? But if you have -1 plus or minus √3 over 2, that's fine. Or if you have 1 plus or minus √3 over -2, that's fine. It doesn't really matter which way the negative goes. So you could say +6 and then -5 in the numerator, and that's fine. That's it. And then taking a look at this last one, I immediately just see 3x squared equals 7. There is no bx there. So this is one that you could just do by square root. No need to factor it or complete the square or anything like that. You're just going to isolate the x and square root it. So divide both sides by 3. So x squared equals 7/3. And then square root it, square root it. So x equals plus or minus the square root of 7/3. And then you have to simplify that radical. Remember that you can't leave it like that. So that's the square root of 7 over the square root of 3. And then I need to rationalize that denominator. So multiply by root 3. So I get root 21 over 3. So x is going to equal plus or minus root 21 over 3. And it doesn't really matter how you do that plus or minus or the divide. Like you could say this over 3, and then you could put the plus or minus more in the middle. It doesn't necessarily matter as long as it's there. Now, quadratic formula can tell you a lot about an equation. It's just kind of a pain to do the whole thing. So down here, this just says find the number of solutions for the functions below. Okay, number of solutions. That means that you don't need to solve it. You just need to find the number of solutions. So right here, you can make a little note. We're not solving. Number of solutions just means, is there 0 solutions? Is there 1 solution? Is there 2 solutions? Okay. And then tell whether the vertex of the graph lies above, below, or on the x-axis and explain your reasoning. Okay. Now, if you're not solving, you can use a part of the quadratic formula that tells you about the solutions, and that's called the discriminant. Okay, the discriminant will tell you about the solutions without solving. Now, the reason that the discriminant will tell you about the solutions without solving is because it goes back up here to our quadratic formula, and it goes to this part right here. If this is a positive number, then you're going to have your plus or minus, and you're going to have 2 real solutions. If I ask you the square root of 64, that's 8. That's plus or minus 8. There's your 2 real solutions, right? But if this were negative 64, you're not going to have 2 real solutions here. You would have your 2 imaginary solutions. You would have no real solutions. You would have 2 imaginary solutions, okay? And if this number just happens to be 0, well, there's no plus or minus 0, so that would give you 1 real solution. So it all relies down on that part that's under that radical, b squared minus 4ac. That's your discriminant. That's going to tell you about your solutions without solving. So if your discriminant, or you can just put d for short, is greater than 0, what that means is that you have positive numbers, you're going to have 2 real solutions. So depending on how you graph it, if A is positive and your parabola opens up, it would look like that. And then there's your 2 real solutions. I can see them on my graph, okay? Remember that solutions just means x-intercepts, right? Okay? Or if it were going down because A was negative, then my vertex would be above and then it would go down to cross 2 times, okay? Now, if your discriminant is less than 0 and it's a negative number, you have 2 imaginary solutions. There's 0 real solutions. Now, I don't care if you say 0 real solutions or if you say there's 2 imaginary solutions. Either one is correct. 0 real is the same as saying that there are 2 imaginary. I just tend to say 2 imaginary solutions because you can still solve it, but you're not going to see those solutions on a graph. And that's because solutions are where my parabola crosses the x-axis. So hopefully you're remembering some of that, okay? So it would be either up here above my x-axis, not crossing it at all, Or if it were going down, I would need to move this parabola down like this, and now it wouldn't cross. Now, if your discriminant is 0, that means that there's no plus or minus. There's no plus or minus 0. So you would have one real solution. And if you had one real solution, that means that this parabola would move so that your vertex is on the x-axis. So either way that it went, your vertex would be on the x-axis. And like maybe it's there, maybe your parabola is over there, but it would be sitting on it, okay? Or if it's going down, same thing, like that, your vertex is still going to be on the x-axis, okay? Now, you don't have to solve to find out how many solutions you have, which is what this said. Find the number of solutions. You just need to see, is your discriminant greater than 0, less than 0, or equal to 0, okay? Now, it still is a piece of the quadratic formula, which means that it needs to equal 0, but I don't have to solve the whole thing, okay? So over here, it already equals 0. I know that A is 1. I know that B is -9, and C doesn't exist, so C is 0 in this case. So when I go to do my discriminant, so B squared minus 4AC, that would be -9 squared minus 4 times A is 1, and C is 0. Well, 4 times 1 times 0 is just 0. -9 squared becomes positive 81. 81 is greater than 0. So I have a discriminant greater than 0. That gives you 2 real solutions. Okay? And that's because the discriminant is greater than 0. Now, if I asked you, so back up here, okay, it says explain your reasoning, that's part of it. Does the vertex of this graph lie above or below? Well, it's a positive, A is 1, which means it opens up, and it has to cross your x-axis, so your vertex is going to lie below the x-axis, okay? So 2 real solutions because the discriminant is greater than 0, and my vertex lies below, and that's because A is a positive number. You could say A is greater than 0. You can also just say like A is positive, okay? So that means that it's going to open up. That's it. I didn't have to do that whole quadratic formula thing, okay? Taking a look at this one, how many solutions does it have? Well, it needs to equal 0, so I'm going to move the least amount of things as possible. So now I have -x squared plus 2x minus 4 equals 0, okay? So A is going to be -1, B would be 2, and then C would equal -4, okay? Always try to move the least amount that you can. So if I do quadratic formula, that's B squared minus 4AC. So B squared, or the discriminant, not the quadratic formula. So B squared minus 4AC would be 2 squared minus 4. A is -1, and then C is -4. Okay? 2 squared is 4. This is 3 negatives, which is going to keep it negative. 4 times 1 times 4 is 16. So 4 minus 16 is -12. Your discriminant's less than 0. It's a negative number. So what that means, if your discriminant's less than 0, is that you have 0 real solutions because you have 2 imaginary solutions. And that's because your discriminant is less than 0. And our vertex would lie, looking that A is -1, that means our parabola is going to go down, and it can't cross my x-axis, so my x-axis is going to be there, which means that my vertex lies below, and that's because A is negative. Okay, like I said, you could just say A is negative is fine too. So the vertex was in the same place as the one before, and that's because A is going to change the direction of your parabola and kind of therefore changes your possible solutions. Because I don't know why I forgot to put that in there. Okay, and And then taking a look at another one. Remember that you want to move the least amount of things possible. So I'm going to move these over there. So when I subtract x squared, I get negative 3x squared. I add 6x, so I get 3x plus 4 equals 0. So that makes a negative 3. That makes b 3. And that makes c 4. And now I'm going to find the discriminant, and then I'm going to use that to kind of tell me about this. So b squared would be 3 squared. Minus 4 times a is negative 3. And c is 4. 3 squared is 9. 2 negatives becomes positive. 4 times 3 is 12. 12 times 4 is 48. 9 plus 48 is 57, which is a positive number greater than 0. So I have solutions here. Because I had a positive number, I have 2 real solutions. Okay? And I have 2 real solutions because my discriminant is a positive number. And if I know that a is negative and it's going down, it's going to have to cross my x-axis, okay? Which means that my vertex needs to be above my x-axis. So vertex lies above. That's because a is negative. That's it. Okay? Make sure that you kind of memorize this chart if you're having a hard time like understanding it. And that goes back to kind of really knowing quadratic formula and how to use quadratic formula. Okay? Now, what if we don't know what c is? This equals 0 already, but it says find c so that there are no real solutions. If there's no real solutions, that means that your discriminant has to be a negative number. So it has to be less than 0. So that means that b squared minus 4ac, the discriminant, is less than 0. So I'm going to plug everything in, and then I'm going to solve for c. And that's going to tell me the value of c that I need to make sure that I get no real solutions. So b squared, b is 5 squared, minus 4 times a is negative 4. I don't know what c is, okay? But I know this has to be less than 0, so it's negative, okay? 5 squared is 25. 2 negatives is going to be plus 16c. I don't know what that is less than 0. And now I'm solving. So subtract 25. So 16c is less than negative 25. And then divide both sides by 16. So you need a c value that's less than negative 25 over 16 if you were going to make sure that this quadratic had no real solutions, okay? Now let's take a look at this in a word problem context, okay? The arc of a baseball into an outfield can be modeled by this function right here. Y equals negative 0.005x squared plus 1.2x plus 3. Okay. X is the horizontal distance in feet that the baseball travels, and y is the height of the baseball. This says, does the baseball reach a height of 50? Now, before you jump too far into this problem, does it? That's a yes or no question. If I ask you, like, do this, blah, 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 like, does this happen? That's yes or no. It either happened or didn't. So does the baseball reach a height of 50 feet? That's going to be yes or no. Okay, which means that this either is going to work or this is not going to work. And this goes back to the discriminant. I don't have to solve this entire problem. I just need to know if it's going to work or if it's not going to work. I need to know if I have 2 real solutions or if I have no real solutions at all, because this is a baseball going into an outfield. If I'm getting imaginary numbers, that baseball is in some weird imaginary realm and this ain't working, okay? So the question says, does it reach a height of 50 feet? And we knew that y is the height of the ball. They told us that. So instead of y, I'm going to replace that with 50. So now I'm going to have 50 equals negative 0.005 x squared plus 1.2x plus 3. Okay? I don't have to solve this. I just need to know if it's going to give me real solutions or imaginary solutions. Okay? Now, to use the discriminant, it has to equal 0. So negative 0.005 x squared plus 1.2x. If you subtract 50, you're going to get negative 47. Now it equals 0. Okay? So A is negative 0.005. B is 1.2. And then C is going to be negative 47. So Coming over here, if I do b squared minus 4ac, that would be b squared is 1.2 squared minus 4 times a is negative 0.005, and then c is negative 47. Okay, I don't expect you to be able to like do this mental math, but you do need to know how to type it into the calculator. So I would pause for a second and go to Desmos because I have not even finished my coffee today. So pause and we're gonna double check that I'm doing this correctly, okay? So I'm gonna go to Desmos and I'm gonna type this in, and that's fine. I wouldn't expect you to do one like this without a calculator to verify things, okay? Minus 4 times a is negative 0.005 times negative 47, and that's 0.5, which is still positive because it's greater than 0, which means that you have two real solutions here, meaning that this is solvable, meaning that, yes, this baseball can reach a height of 50 feet. So how are you going to write that? Using words, because this is a word problem, you're just going to say yes. And clarify, yes to what? Yes, the baseball will reach a height of 50 feet. That's it. Now, remember that quadratic formula is your last result, right? Quadratic formula is your last result. If you don't have to solve it, you just need to know about the solutions. That's where you can just use the discriminant. So you don't have to even do the whole quadratic formula. If I just ask you to classify or about it, that's where you can do this stuff right here, okay? But if you have to solve, you really want to know what are your other options, okay? Do you want to factor, square root, complete the square quadratic formula? So down here, let's take a look. It doesn't say to solve, it just says which method or methods would you choose to solve, and then let's explain it. So if I take a look at this first one, I'm immediately seeing that there's no bx, so this would be a great one to solve by square root. All you would need to do is add the 9, divide by 3, square root it, right? And that's just because there is no bx, okay? But if I take a look at this next one right here, I can't solve this by square root. I don't even want to try to deal with factoring because 6 times 17 is going to give you a pretty big product and then trying to find those values, right? Okay, so maybe it does factor, but do I want to spend the time to try to think of all my factors, right? I don't want to do completing the square. This is not 1, that's an odd number. This is a situation where quadratic formula would probably be best. If you have to spend 20 minutes trying to decide if something factors, just go to your last resort. Okay, and then taking a look over here, okay, a is 1. I can't solve by square root. This is an odd number, so I probably don't want to complete the square, but I can just check to see if it factors, right? So sum to negative 1 and a product of 1 times negative 30. Well, hopefully it kind of comes to you fast. That's just negative 6 times 5. 6 times 5 is 30, and then negative 30, so negative 6 and positive 5. This factors, so I would factor it. Why? Because I would just say it's easily factorable. It wouldn't take you forever to come up with those numbers. Okay? And then for this last one, if you had x squared minus 8x plus 3, if I try to factor this one, can't do square root, sum to negative 8 and a product of 3, well, it's not really factorable. I probably wouldn't want to do the whole quadratic formula because a is 1 and this is even. I would complete the square here. Now, it is important to note that you could do factoring, like if it factors, but you could do completing the square quadratic formula really anytime. It's just quadratic formula can be a bit of a beating. So you always want to go with what you feel like is probably the best method, okay? So on your assignment for today, if you feel like factoring, factor. If you can factor, right? If you feel like completing the square, then complete the square. You don't have to do quadratic formula on all of them. That's really just your last resort. So kind of fill them out. If it factors, factor it. A is 1 and B is even, complete the square. If you can solve by square root, solve by square root. Just remember that quadratic formula is going to be your last resort, okay? Good luck on your assignment and on your test, and I will see you on the flip side.